Hello class, these are calculus notes for section 7.2 and I've made this into like a 7.2b because it was just too much information to do all of the chapter in one day or all of the section in one day. So we're looking at example 6. This is directly out of your book, and I went ahead and just did like a scan from your book so you could see the whole problem in color. It says find the volume of the solid shown. The base of the solid is the region bounded by the lines f of x equals 1 minus x over 2, g of x is negative 1 plus x over 2, and x equals 0. And then down here it also says the cross sections are equilateral triangles. So first we need to understand why this is different from the examples that we did yesterday. And before, what we were looking at is we were looking at my y and my x-axis, and maybe there was some kind of a line here forming like a triangular shape. And then we were taking that shape and we were revolving it around an axis, either the x or the y-axis, but in this case the x-axis. So then what happened is I ended up making something, how do I want to word this, so that my cross sections were circles, right? When I revolve that around, I end up with some kind of like cone shape basically. And so all of my cross sections are circles. I'm going to have pi in my formula. So you can see from the picture below that that is not what we have at all. My kind of shape is like coming up out of the paper almost, I would describe it. I have no idea what I just did with my paper there. Oh, I just made it really, really big. My shape is coming up out of the flat sheet of paper, and it's not revolving around anything. My cross sections are actually just triangles. So you can see what's going on here. If I go down below, this is what it would look like on my y and my x-axis. So here's my y-axis, here's my x-axis, and I've got this little shape that's like a triangle flat on my page, and one of those lines is formed from the negative 1 plus x over 2. The other line is formed from the 1 minus x over 2, and then coming up out of this shape are a bunch of triangles. And on one end where my base is really wide, I'm going to have like a really big equilateral triangle. And then over on the other end where my base is really small, right, because these two lines are closer together, I'm getting really tiny triangles. So that's what we're going to be trying to find the volume of. So I'm going to go ahead and erase some of my work here. And I think the first thing is we really need to know the formula for equilateral triangle, for the area of an equilateral triangle. Because essentially what we're always doing to find our volume is going to be some kind of from A to B integration, and then this is going to be the area of a cross section, and then like a dx or a dy, right? That's what we're really doing. We're integrating all of those areas, and that's giving us, the accumulated area is giving us a volume. So if I look at area of an equilateral triangle, and in class I just gave you this formula, but here I just want to take a second to derive it. I want to think about the properties of an equilateral triangle. And I want to think about how this is a 60-degree angle. So if I drop a perpendicular here, now this side is essentially b over 2. This side is of course b. I'm just using b for base. And my other side, remember, it's going to be my small side times the square root of 3. Because remember how they have that 1 to square root of 3 relationship. So it's like this side here, the 1 times the root 3. So my vertical side would be root 3 times b over 2. And then if I am trying to find my area of this triangle, so let's remember to find the area of a triangle, it's going to be 1/2 my base times my height. Well, my base is my entire base is b, right? From here to here is b, that's my base. And then my height is that root 3 over 2 times base. So that means my area of this is going to be root 3 over 4 times the base squared. So that's going to be my area of an equilateral triangle. That's what I've got going on here. And I just gave you this equation in class. I don't want us to have to derive it every single time we need it. It's just better to memorize. So if I am looking at my area of a cross section is an equilateral triangle. Oh, I got to get my pen back here. That means I can write root 3 over 4 times base squared dx. I'm going to be integrating along my x-axis from 0 to 2. But I've really got to figure out what the base is. So what is the base here? Well, the base is going to be my distance from one of these lines to the other line, right? That's my base. My base is connecting those two graphs. So my base is going to be the top one, 1 minus x over 2, minus the bottom one, which is negative 1 plus x over 2. So let's go ahead and simplify that. So negative 1, that'll be a positive 2. Maybe I'll do an extra step in here just so I don't screw something up accidentally. Sign errors are the mistakes we make. So let's see, it's going to be 2 minus 2x over 2, which is just 2 minus x. That's my base. Okay, so now let's put it all together. That means my volume is going to be the integral from 0 to 2 of root 3 over 4 times the quantity 2 minus x squared. I'd want to put my constant in front, and I would also want to expand that. A lot of what we end up integrating this chapter is just using power rule, but that doesn't mean we can't make lots of silly errors, right? So, and I want to erase this right here. That's all in my way. I don't know why it won't erase. That is really weird. There we go. Okay, so now let's go ahead and integrate. Root 3 over 4. So let's see, the 4 is going to integrate to, I guess I could really have integrated the other way too, but I think we're more comfortable expanding. Oh, you know what? I did screw this up though. This should not be a 2 because we got to do 2 times x and then double it. So it's going to be a 4x. Good thing I was taking my time doing something else. So when I integrate 4, it's going to be 4x. This is going to be 4x squared divided by 2, so minus 2x squared, x cubed over 3. This is all from 0 to 2. So 4 times 2 is 8, minus 2 times 2 squared. Well, 2 squared is 4 times 2, so that's also 8. So like these guys are gone. Plus 2 cubed over 3 would be 8 thirds, minus, I plug in 0 for all of them, it's just 0. So nothing to worry about there. So I end up with root 3 over 4 times 8 thirds, which is going to be 2 root 3 over 3. All right, so it doesn't have to be a triangular shape, right? It could be that your shape is a square. And so you've always got to think about like, what is that area of a cross section? So if it's a triangle, it's going to be some kind of triangle formula, right? If it's a square, it's going to be whatever my base is squared. Maybe it's a rectangle with a height of 1. And so you're going to have like a base times 1. Maybe it's a, I'm running out of shapes here, but you've got to really think about how we're integrating the area of a cross section. That's what this part of the notes is all about. So as always, class, if you have questions, please make sure you ask.